but it's okay. I recorded my previous lecture. I'll put that in there. Okay. Thank you. Thank you, Vincent. I appreciate it. All right. So that's one-to-one function. Well, then what do we do? Okay, let's look at some examples. Okay. So next, look at the 8 functions we studied. Do we know which one is one-to-one, which one is not one-to-one? Very quickly, right? You can decide which one is one-to-one, which one is not. For example, you can just quickly do, we know all of these are functions. You just do a horizontal line test, right? Which one is one-to-one? This guy is one-to-one, right? This is a one-to-one function. This one is a one-to-one function. How do we find the inverse? Okay, so next it comes to how to find the inverse, right? We know that one-to-one function has all these interesting properties, right? How to find the inverse functions? How to find the inverse function for a one-to-one function? Okay, how to find the inverse function for a one-to-one function? We know that there's one and one only. Okay, so in your past experience, you might have learned this, but we're going to do it all over again anyway. Okay, one of the things we do is that, for example, this one. For example, this one. Okay, what we do is that we're going to remove this guy. Okay, there's 2 steps for it. Step 1, swap. Swap x, y. So x and y are swapped. If you don't remember this, that's fine. If you remember this, great. No big deal. You're learning it, okay? Swap. So in this function, we're going to turn y into x, x into y. This swap also marked behind the scene the swap of domain and range. Because f has a domain, okay? This f, what's the domain, what's the range? This is the domain and this is the range, right? So we have domain range. The domain range was here, right? This guy. And then with this swap, the domain range is swapped. So this becomes what? Range. And this has become domain. And we put this number in the domain, well, whatever we call it, and this is going to be 1 over x. Okay, but sometimes people like say, hey, y is not 0. So y is not 0, right? So we put this over here, just watch this, okay? So when we swap these, right, domain becomes range, and range becomes domain, right? Input is x, output is y. You see that swap. When we swap a variable, the variable carries with it its a shadow. Its a shadow is domain and range. Follow me? All right, always. Okay, what we're talking about is always. Not just today and tomorrow, always.
Sir, is the range change the value because copy pasted? Is the range correct? Can we check it? On the original function too, y equals 1 over x, domain and range.
Right, because here, y is 1 over x. Okay, I just don't want to confuse people at this moment.
Okay.
Okay, so this really also means y is not a 0 either. Okay, we're going to discover, we're going to solve for y here. Okay, so if you have any confusion, just wait a little bit. Okay, just wait a little bit. Step 2, we're going to solve for y. We're going to solve for y. Okay, when we are solving for y, what do? From here, we're going to isolate y. So what we do is we treated x as x over 1. Yeah, can we do that? Same thing, right? And solving for y, we just flip on both sides, and we get 1 over x, and the other side is y. So y equals to 1 over x. This is the only function in the wide world that the function and its inverse are exactly the same. Isn't that so interesting? This is the only function. I haven't found another one, in other words. So I have made that claim. Okay, if I'm wrong, please come back to tell me. I think this is the only function. Its inverse is the same as the function. Okay, so when you talk about domain and range, in this setting, right, the domain is x is not equal to 0 and y is not equal to 0, and y is equals to 1 over x, right? But for this one, the domain, because we have a swap, right? We have a swap. So the domain is going to be this guy. The range is also 1 over x. Peruz, you want to say something? Is there any problem here?
No, I just, as you said, I needed to be patient. Thank you.
Okay. So I just want to swap place with domain and range, because typically we write domain. We put domain here. We put domain on the top and range at the bottom, right? No problem. But this function is interesting because its domain and range are exactly the same, right? The domain and range are exactly the same. Okay, so now let's see. We found the inverse. Yay. We found the inverse. And the inverse is 1 over x as well. Okay. And let's look at that loop. Let's look at that loop. 175%. Okay, so that way you can see the negative sign. Okay. The swap of domain and range all happening at the same time. So now let's look at a couple examples. I want you guys to roll up your sleeves. Okay, so now we have 2 rules, right? We have these 2 rules, right? This is one rule. We have 2 rules. And in this concrete example, I want everybody to roll up your sleeve, have your paper pencil with you. And we're going to do some work. We're going to do some work. The domain, okay, f, so the inverse is this, the function is this, right? So now we know everything about this function. So f of x. These are 2 functions. They are inverse to each other. Let's see what else property we have for them, right? So now that we know the domain too, right? What's the domain here? The domain here is, x is not equal to 0. And what's the range? The range is what?
Y is equal to 1 over x, but not equal to 0.
Perfect. Perfect answer. 1 over y. Oh gosh, what am I doing here? So this range, thank you for your patience with me. Okay, the range is, sometimes the symbols is gonna may confuse us. Okay, but just just ask, okay? So y equals to 1 over x, it is not equals to 0. Okay, that's the range. And this domain, once again, is x is not equal to 0. Then you say, hey, this is x and this is x. Are they the same thing? They're different. Even though they have the same name, they belong to different category. Okay? This x is from the domain of f. This x is from the domain of f inverse. You follow me? It is a special situation in our case. The domain and range happen to be the same, and all of these 4 cases are the same. Are there cases that are not? Yes, we're gonna get to those. We're gonna get to those. Do you follow me? Now, range. What is the range for this other guy? Same thing, right? So I'm just gonna put it here. You can use the same symbol, even. But you need to understand which one is input, which one is output. I know it's a little bit confusing, okay? It's a little bit confusing. Any questions so far? I'm trying to go slow, but not too slow. But I want to take care of everybody. Any questions so far? I want you guys to experience the process. Okay, so I'm going to show you an example, and then we're going to work maybe in
Professor, I have a question.
Yes.
I apologize if you went over this already, but the significance of having the any real number before the range on F versus no any real number symbol for F -1.
Which one you're addressing?
So the symbol right before the range for function F.
Yes, this one?
That symbol is missing in the second statement.
Oh, okay. I'll put it there. Anything else? Thank you.
Oh, thank you.
That's all?
Yes, my question was if it's significant, but it sounds like it wasn't.
No, it wasn't terribly significant, but it's good to be there.
Okay.
It's basically saying that this is a part of the range. This is one element of the range. That's what it says. Okay, it's a totally, I know it's a totally new world, and then for most of you, and including myself years ago, this math language, I mean, let me tell you, it's pretty tough to get them through. Okay, I'm just sharing with you my learning experience. Okay, all right, good. Any question, please bring them on. Okay, it's never too late. It's never, don't worry about it. Okay, just move on to ask it. So what I'm going to do is that I'm going to give you an input. This input I'm going to choose is going to be x equals to 2. Okay, so I'm going to have this x equals to 2. Okay, this number is going to be given to f. And you're going to tell me what will be the output. How to find the output. And then what you do is that you take the function, right? The input is 2, you replace x by 2, and you plug in. So the output is what? Is half. You guys see that? Is that easy to do? Do you want to try one? That's how you produce the input from input output. You follow the rule. Remember, function is a rule. So I'm going to give you a couple numbers to do. Okay. X equals to -2 is given to f. and you're going to produce the output. And I'm also going to give you x equals to 3. I'm going to give you F inverse. And you're going to produce that output. Okay, so you're going to produce 2 output for 2 different input for 2 different functions. Can you do it? I'm sure you can. If you want to work with Farouz, you want to, shall we create a breakout session?
Yeah.
Okay. Breakout rooms. Participants choose your rooms. Farouz, you ready?
Yes.
Thank you.
I go to breakout room. I see Maximilian.
Professor, you're on mute.
Professor, you're on mute.
Thank you. No wonder. No wonder. Thank you so much. We cannot hear you. Thank you. Appreciate it. Okay. So what we're trying to do here, we haven't done the loop yet, okay? Some people call it loop, but I'm not going to call it loop yet, okay? Is that you have an input. If the input is in the domain of the function, all you have to do is just plug in. So the output here is going to be just -12. And for the input of 3, this time our rule is F inverse. So I'm going to take the F inverse function and plug in the 3. And plug in the 3, so I'm going to get 1/3. So this is from input. So this -2 is from the domain of F. The +3 is from the domain of F inverse. So there's a difference. There's a difference, okay? So now, let's do a few more. Suppose I take this input in -12, okay? -2. -2 is in the domain of F inverse, isn't it? Because F inverse has a domain of any number but 0, right? And from the domain of F, we get to the range of F, but the range of F is also the same as the domain of F inverse. So F -12 certainly is in the domain of F inverse. So I'm going to apply the rule for the inverse function. So -12 is going to be the inverse, the input for the inverse function. What do I produce? I shall produce an output by substituting -12 into the input here and substitute it over here. Does everybody see it? Does everybody see it? And this is a complex fraction, isn't it? How do we simplify this complex function? Sorry?
Multiply the numerator and the denominator by -2.
Sure. You can multiply the numerator and denominator by -2. So you're using principal number what? Number 1, right? So multiply the numerator and denominator by -2. 1 times -2 is -2. -12 times -2 is 1. So the final answer is -2. Look at this. The input is -2, goes through F. Right, so let's cut off some of these little details. Okay, let's cut some of the details. -2 as the input going into F produces F of -2, and which is -12. And -12 serve as the input, go give it to F inverse, and F inverse produces an output, and this is -2. And this -2 is exactly the same as this -2. And we just wonder, is this just accident? Is this by accident? Okay. So how do we describe this process? Number 1, is this an accident? Number 2, Is there a way to describe this process? The answer is yes. What we do here is that we have f of inverse of -1/2 is equals to -2, right? But what is equal to f? What is equal to -1/2? -1/2 is also the same as f of -2. So I can replace this -1/2 by its equal, which is right here. So f inverse on f of -2 is going to be -2 exactly. So the question is this just an accident or is this is always true? Okay, so let's take a look. Right? If I apply this rule, this process, if I apply this process, okay, instead of using -2, I'm just going to use any arbitrarily chosen number from the domain of f. And I will produce an f of x. And that f of x is, of course, is going to be 1/x. I'm going to take 1/x and I give it as input to the inverse. So this is going to be, this piece is going to take 1/x as input, right? So this is going to be the input. And what would that be equal to? How do you simplify 1/x? What do you do?
Multiply the numerator and the denominator by x.
Perfect. You multiply numerator and denominator by x. And what do we end up with? X. And this is true for any x in the domain of f. Right? Because this x is from the domain of f. And that mathematical form would be what? F of inverse. That equals to x, right? And 1/x is equals to f of x. So this is always true for any x from the domain of f.
Professor, is x cannot be equal 0? Does it need to be mentioned?
It doesn't need to, because, well, you could, it's not necessary because the domain of f is already not equal, x is not equal to 0.
Okay.
Okay, but if you want to make it shorter, you can say, you could just mention that it's not equal to 0, which is you already mentioned.
All real number except x equals 0.
Exactly.
Thank you.
Okay. Any questions? So you can see the shorthand notation you're going to see here, right? This is a shorthand notation, you're going to see it here. So I'm going to give you a couple of examples to practice this because I believe that this might be a little new to us, right? Okay. So what I'm going to do is I'm going to give you a couple of numbers here. I'm going to give you a 5. Okay. You can use the machine because this machine is actually substituted by the simpler form of mathematical notation. So I'm going to show you the example, right? So I'm going to show you the example. If anybody has any questions, so please don't hesitate to ask. Okay. So then I'm going to show you an example. Okay. Example. Okay. F is such, F inverse as such, right? So when you go through this process, what do we get? You always start from inside out, okay? So you're gonna have f of inverse first, and f of 5, right? For f of 5, you're gonna do it, you're gonna replace this x by 5. You guys see that? And f of 5, the consequence will be 1/5. You follow me? Yeah? And then f inverse of 1/5, so you just put this 1/5 in here, and you're gonna get 5. Do you follow me? And now you're gonna get 5. Does everybody follow me? So isn't mathematical notation is simpler than the machine drawing? And if you know the property, if you know this property is always true, you actually don't need to go through this. You can just say, hey, it's going to be x without having to do anything. Okay?
If the functions are one-to-one.
Yes. If the function is one-to-one, because we're discussing this, we're still discussing this function is one-to-one. Now,
Yes.
so f inverse outside, f is inside. And this is true. Now the question is, what if we switch these two? Would that still be true? Right? Will that still be true? Now, suppose I give you f of f inverse. Equals to, what would that be? This one from inside out, basically you say, okay, I'm going to give it to x, and the function that's applied to it is f inverse. Because we always do it from inside out. Comes out f inverse of x. And this guy will be used as the input for f. And then it will produce f of, okay, this is the input. This goes here. Guess what this will be equal to? It's going to be, this piece is going to be 1 over x, right? And over here, it's going to be 1 over x. So it's going to be equals to x. So this is still true. It is not only true for this function, it is true for any two functions that are inverse to each other forever. Okay, so in this case, it's true. It's going to be true forever. Okay, so this is true. And this is true. But true for any x in domain of f. Okay, but this is a more general statement. These are more general statement because up to here, we're still discussing this example. Do you guys follow me? Up to here, we're still discussing this example. And in these other one, in some situation, the domain may not be the same. Okay, So this X is in domain of F inverse. Our time is up. Okay, our time is up. But tomorrow, we're going to talk about another function and its inverse. And next time, you will see some situations that domain and range are not the same. Domain range are not the same. Okay, so this is one of those special examples, but this function is so important. Okay, you're going to touch this function in calculus classes in its various form. So we cover this function from this perspective. And so this is a general statement. So for if, okay, if F and F inverse, if F and F inverse are inverse to each other. Okay, so this is the piece that's true forever. It's true forever. Okay, so you're gonna see this fact being illustrated over and over again for different functions. So that's gonna be the task we're gonna do in the following lectures. Okay, if you have any questions, so please don't hesitate to ask, and I will make every effort to make you understand. Okay, I will see you guys tomorrow.
Thank you, Professor.
Thank you.
See you tomorrow.
Goodbye, Professor.
Thank you for your effort. Bye. Thank you, Vincent, for reminding me.
You're welcome, Professor.
I appreciate